Hi all, welcome back to the channel. Today we will look at 7 concepts to increase your Git productivity exponentially. If you are using Git, after learning them you will be using them regularly. Before the video starts, I want to let you know that this video will make sense to you only if you know the basics of Git: push, pull, commit, branch, etc. And one more thing, I will be adding chapters to my video so that let's say you know some of the concepts, you can just watch the concepts you don't know. So without further delay, let's get started. So let's get started with the first concept, which is Git Worktree. Git Worktree is one of the best concepts Git has ever given. To learn Git Worktree, I will tell you the problem we faced before Git Worktree, the solution we did, and then what Git Worktree bring after that. So the problem was this. Let's say you are working on a feature and your changes are still half-baked. You don't want to commit them yet. But let's say you want to review some code or work on a hotfix, which is more priority for you now. What you can do now is either clone the whole repo in another folder so that your changes won't be affected, or what you can do is git stash. This is what I used to do previously. I think many people do this. What we do is we add our changes to a stash here, and then once we are done with this work, we come to this branch back here and we pop back the changes. So this guy will be added to the stash and will be brought back after the work. This is what we used to do. Let me show you how it works in the terminal. So this is my demo branch. This is what the status is. I have my half-baked changes here. I cannot commit it now. What I will do is I will be doing a stash. As you can see, I did a git stash and it is saved. So what you can do now is you can list the stash. You can use this git stash list command. As you can see, stash 0 has work in progress on feature CS1 and it is still there. One more thing I want to show you is status. So as you can see, all the changes which were there, which were half-baked, are gone into a stash. Now I have a cleaner working tree. And then I can move to a different branch, do my work and come back here. Now what I have to do is I have to pop my stash back. Once I do this, I have my changes here back. What I did before and what I added in the stash. I have all the changes here and now I can continue working on my branch. As you can see, git stash list is not showing anything here. The stash has gone. There is nothing here. And we have got our changes back. And this is the status of our current branch. This is what we used to do before Git Worktree. This is the same thing we did in the terminal. Okay. This was a good approach, but this was kind of annoying. And the cons with this is let's say I have a huge code base and which takes time in compiling. So when I go to a different branch and come back to my branch, it is compiling my code 2 times, and let's say it is taking 20-30 minutes to compile. Then it will be a nightmare for me. It will increase my development time. Second thing is I want to keep my changes as it is. Sometimes I do so many stashes that I forget where my changes are. That is a problem with many of us actually. So that's why git stash was a solution, but not an efficient one. Then came Git Worktree. So as you can see with stash, at the time of stash, we can have only one folder for one repo. If you can clone the same repo in a different folder manually, but if you have only one repo, you will have to have that in one folder. Git Worktree gave us something we needed badly. As you can see, what Git Worktree does is you will have multiple of your branch opened in different folders, but there will be a main Worktree, which will be the true repo. So as you can see, my feature CS1 branch can be here. And now let's say I want to go work on a hotfix. I can open a different Worktree, which will be my working copy 2, which will be in a different folder, and I can call it Worktree 2. So the true repo, the first repo which we have, will be called the main Worktree, and it is also called the true repo. We will have Worktree 2. It doesn't have any special name, so we will call it Worktree 2. So there are multiple working copies of our repo in multiple folders, and our changes are untouched here. One more thing I will recommend is making your working copies in different folders. Don't put your working copy 2 in working copy 1. You will have duplicate changes of your working copy if you just put your working copy 2 in your working copy 1. It will consider them as files. One more thing I want to tell you is you can run any command in both the worktrees. One difference I found between two worktrees is our main worktree will have .git folder, which will have our repo metadata, our work tree true, we'll have a .git file which will point to the main work tree. I will show you everything in the demo. So let's go there. As you can see now, this is current state of my repo. I have my Git repo in this folder. Okay, there is only one folder as of now, our main work tree. Let's create a work tree with a different branch. So let's see all the commands before creating our first work tree. This is our Git Worktree add, Git Worktree list, Git Worktree log, Git Worktree move, prawn, remove, repair, and unlock. There are so many commands, and to explain all this, we'll need a big video. But in this video, we will just look at the basic commands. Other, you can read the documentation on GitHub. It is very nice documentation, and you will get a lot from it. But the basic commands we will cover here. So let's create our first work tree. This will be the command I will be using to create work tree. As you can see, Git Worktree add here. This is what the command is. -b is to create a new branch from this branch. So this will be my branch name, and this will be from my release branch. Okay, and this is the path I want to place my new work tree in. So as you can see, I did dot and code review, which means I want to make it in parent directory. I will go back one step, and in the parent directory, I will create a new folder code review, and it will create a work tree in that folder. This is what I recommend doing. Don't put your second work tree in your first work tree. As I already told, it will make you push the duplicate changes. We have prepared the work tree. I was having issues with my older terminal, so I reopened the terminal and ran this command again. As you can see, this is the same command which I showed you previously. Now it is showing the work tree is created with branch hotfix -code review, which is created from branch release -cs1. I will show you the top view, how it is created. As you can see, this is our main work tree, and this is our work tree which we have created. Let me show you the side-by-side folder view as well as the terminal view. So this is side-by-side folder view as well as side-by-side terminal view. Let's see the folder view first. We have a Git folder here. As I already told you, this was our main work tree, and we have a Git file here in our work tree too. As you can see, this is the branch opened here, and as you can see, this is the branch opened here. I have ran git status command in both the branches. As you can see, we can run any git command in both the terminals. There is no difference. They are both part of our Git repo, but it is in a different work tree. As we are done with this, let's move on to our main repo, as I want to also show you one more command. This command is used to list the work trees. So as we saw the folder view and we saw the terminal view. We can do this also. As you can see here, we have two work trees. One has this branch, one has this branch. Heads for both are same as of now, because I have not done any changes in my second work tree. But if you do work on a hotfix, commit anything, the head will look different. So as we are done with this, now what can we do is we can remove the work tree once it is done. You can keep the work tree. Let's say we had a problem, right? That let's say our code base is very big and it will take 20 minutes to compile it. So we can keep this work tree for some time, and we don't want recompilation to happen. We can keep the work trees which are needed. For me, I keep my release branches, the current release, whatever we have to give, I will keep that open. Let's say something comes up in that, and also I will keep some of the branches open which needs regular code review. I will keep that open in my work trees. So let's remove this work tree. This is the command we will be used to remove the work tree. As you can see, git work tree remove, and the path, it is successful. Let's see the folder view. As you can see, our work tree is gone. So this is it in work tree. Let's move on to the next concept. So now let's move on to Git Squash. Git Squash is not a command of Git, it is an option. Git Squash is used when you want to take a lot of your commits and squash it into one. It is used to make your history very clean. So to understand more, let me give you an example. Say you are working on a hotfix, right? And your manager says that you have to give this hotfix with this feature only. Let's say there is a weird situation like that. And let's say you have made a lot of commits in your hotfix. Some of the commits which you don't want to include in Git history. But remember, the bigger your Git history is, the bigger challenge it is to track the changes. Okay. So you want to keep your Git history concise and clean. You did some basic changes like change the color if you are working on a UI, and change some documentation, small documentation, and you have committed this. But you want to make your history cleaner. You want to merge all your commits, which are very simple changes, into a single commit and push it into your branch, which will make your history cleaner, right? So for that, we will use Git Squash. This is the option given by Git. There are two ways to do it. One is with the interactive rebase and one is with git merge command, which we use. So I will show you both the ways. Let's go to the terminal. I have these two branches. As you can see, they are on different heads. They have different commits on. And let's say I want to merge them in my release branch. Focus on this branch first. I will be using a command called git rebase -i for the interactive rebase. Let me show you the history first before running the git base command. This is the history. I have my base commit, as you can see, 09196, which is commit where my head of release branch is. So this is the current head of my release branch. And after creating this branch, I have done these 3 commits. Silly commits, right? Code refactor, code refactor, code refactors. I just have to refactor a code in my, let's say, this branch, and I am merging it to the release branch back. Okay. But I don't want to make the history like this, like 3 commits for the code refactor. I want to merge all these changes in a single commit called code refactor and merge into my release branch. Okay. What I can do now is I can rebase in the current branch and then merge to my release branch, raise a PR or merge it. Okay. Ideally raise a PR. So I can run this command, git rebase -i for the interactive rebase, head ~3. So what it tells Git is you take 3 commits from the head with head included. So as you can see, our head is here. It will get this commit, and this commit, and it will start a rebase process. So let's enter. So as you can see, it has given all 3 commits here to us. What I will do is I will pick this commit, I will squash these 2 previous commit into this commit. Okay, and it will all become a single commit. So let me do it. As it is a VI editor, we have to do I, and we have to add word squash here. Okay, let's save it. So as you can see, it is showing me all the combination of 3 commits here. We can change the commit message also from here. As you can see from rebase, I want to keep this code refactor commit message. What I will be doing is I will be commenting these 2 commit messages here. Let's do I, and let's come here, and whatever is in hash, it is a comment. So I will be committing this to, and I will be saving it. Let's see the log. As you can see, I have only 1 code refactor commit message with crypto service here, and now I can raise a PR or merge my branch by using git merge. Let's see a different way. So I have moved to my feature CS2 branch. The situation here is also same. I have 3 crypto refactor commits and I have crypto service added. I have to merge this in my release branch. So let's move to our release branch here. I am in my release branch, and let's do a git log. We have crypto service added here. There is no other log, and you can see the log of my feature CS2 branch, which is this. So let's proceed with the normal merge here, and we will see the git history, and then we'll do a squash merge. Okay, so git merge, and it will be my feature branch, which is this. It is done. Let's see the git log. Now you can see my history is like this, very long, and it doesn't make any sense, and it is kind of annoying, right? I will reset to this commit. If you don't know, you can use this command to reset. Now let's see the git log. As you can see, it is back to this commit. So my release branch is back here. Now let's merge with the squash option. Let's see git log here. Now you must be seeing that there is no commit added, right, after the merge also. But as you can see, after the squash, I have changed these 2 files. So what squash does here is it will get all the changes and merge it into this branch, and then it will not commit it. But if you see my git status, as you can see, these are the changes I did in all those 3 refactor commands. So all the changes will be merged to this branch, but will not be committed. You can commit it and give your commit message, and you will have only single commit squashing all those commits. So it will be same. So let's do it. Now let's see the git log. As you can see, I have committed all the 3 changes which I did. As you can see, I have added, I have committed, Now my Git history looks something like this. Okay, so this was Git Squash. Let's move on to the next one. Let's move on to Git Aliases. So personally, I use this command a lot. Git log -1line -graph and -decorate. This will show me the Git history here, and it is quite long command. Okay, imagine while working with Git, how many times you will write this command. It will be a lot, right? To make it simpler, Git has given us a concept called Git Aliases, which we can use to shorten our commands or give them a nickname, is what I can say. So let's say, you can do something like this: git config -global. So I am changing the global config here, and I am giving the alias as logs instead of git log. When I put git logs, it will run this whole command. So you can create your aliases like this. Personally, I have not created the aliases because I like typing commands, but trust me, it will save you a lot of your development time. Imagine writing this again and again, like at least 100 to 200 times a day. If you are working with Git and you are a caretaker of a open source project, then this aliasing will save you a ton of time, and you can use the time in drinking some coffee or something. So this will help you a lot. So this was a very simple concept. Let's move on to the next concept. So let's look at Git Bisect. Git Bisect is a tremendous concept. If you know this, it will save you a lot of time in case of regressions. So you might have already faced this scenario in your project that something which used to work is not now working, which we call regression, and it is causing a bug for you. Now what you can do is you can just find the commit where it was working. Let's say it was working here, and now here it is not working. Simplest thing you can do is you can do a binary search between these two, take a commit between this and check if it is working here. If it is not working, then you will see this commit. So this is the simplest thing you can do, and which we were doing before Git Bisect. Git Bisect does the same thing. We will mark a commit as bad and other commit as good. Then it will do a binary search, which is more efficient than you, by the way. Then let's say it come here. We will run some test, or we will run some unit test that our stuff is working or not here. And then if let's say if it is working here, then it might have gone bad here. It will do a binary search between these two. So the same thing it will do. So let's say if you have like 100 commits, right? It will be log of 100. It will be not much. It will be just log of 100, and it will be very easy to find what caused this bug. Personally, what I do is I create a test file with Git Bisect, and on every commit, I will run that test file, and once it runs perfectly, then it is passing, then that commit is good, and if it is failing, that commit is bad. Let me show you in terminal how you can do it. First thing you have to do is you have to start the Bisect. Before that, you can see the log here. I have 1, 2, 3, 4, 5, 6 commits here. This will be my initial commit. I did some changes, and I am here as of now. And here I found out some regression. Something which used to work is not working. Okay. Where it used to work? Here. And where it is not working currently is here. We don't know which commit caused that. Right? Start the Git Bisect. So you can do that by doing Git Bisect start. Once you start the Git Bisect, it will wait for both good and bad commits. What we will do is we will mark our current head as bad commit. You can mark your current commit as bad using a simple command called Git Bisect and adding bad. Once we add bad, it is waiting for a good commit. You can mark your commit as good by using simple command called Git Bisect good and your commit ID. Since we were on the head, we didn't have to give the commit ID at the time of bad. If you want to mark some other commit as bad, you can add the commit ID there. But in general cases, you will face this. It is not working in your current head. So let's mark it as good commit. So as you can see now, it has started Bisect, and currently we are not on this commit. Previously where we were, now we are on this commit, which is F25. As we mark this as, so we mark this commit as bad, we mark this commit as good, and now Git is thinking that this commit might be the culprit which added that regression. So it has switched to this commit. Now what we'll do is we'll run the test here, and then either we will mark this as bad or a good commit. If you mark this as good commit, then the culprit will be either these three. it will do a binary search between these and these. It will repeat this process until you find the culprit. Okay. So let's mark this as a good commit, or let's switch it up. Let's mark this as the bad commit. So what you can do is a simple command bad, and you can give this as a bad commit. Okay. Then as you can see, it has switched to this commit because it will not check here because this is bad. So all the commits above from this will be bad. So to find the culprit, it has to go down the line, right? So it has gone down the line and it is checked out this commit. Now you can run the test case here and you can mark it good or bad. So this process will repeat itself and you will eventually find the culprit. One problem I faced in this process is the test file. Okay. So let's say you created a test file, and now when you will go to a different detached head here, will go to a different commit, the test file will be gone. Okay. So what I do here is I will create a new test file. So let's say I'm working on a Java project. I will create a new test file. I will add that in Git ignore. So Git won't be tracking it, and I will be switching my branches, running that test again and again. And once I found the culprit, I will run that test. Once I will found out the solution for it, and I can solve the bug. So this is it for Git Bisect. Let's move on to the next concept. So let's move on to Git Cherry-Pick. Git Cherry-Pick is the command which has saved me a lot of time. Git Cherry-Pick you can use to selectively take a commit and merge it into another branch. It can be a single commit or it can be multiple commits. It is used in many scenarios. Let's say you are working on a feature and there is a bug fix. Now you want to merge that bug fix to the release branch because let's say people who creates branch from that release branch also should have that fix, right? So what you can do is you can take the commit, selectively cherry pick and merge it into this branch. So let's say this was my release branch, this was my feature branch. I resolved the bug here and I have my feature here, but I don't want to merge this whole branch to this release branch because my work is not done yet. But I want to merge this bug fix which I did here, this commit to this branch. So I can use Git Cherry-Pick to just selectively merge this commit to this branch. Also, you can do backporting using this. Let's say you have main branch or master branch and you have your repo as open source. People will see your master branch regularly and will try to clone in their local and run it. Let's say you have a bug there and you are working on a feature. If you just directly wants to merge a bug fix to your main branch which is older and your feature branch which is newer, here same concept, you can just selectively merge that single commit to that main branch. Also, let's say you have some lost commit and you found out that lost commit using Git Reflog or some other way. So you can just get that commit and cherry pick to your branch and get that commit back. So there are a lot of use cases where you can use Git Cherry-Pick. Let me show you the demo which will clarify everything. Here you can see we have three branches. One is my feature branch, one is my release branch, and one is my main. So I will be showing just one cherry pick. It is easy enough, you can do it your own. So let's see Git log here. Currently we are in feature branch. Yeah. So this is the initial commit where my release branch is also there, you can see. And my feature branch has two new commits, A change, B change. So I just want to merge my A change to my release branch. Okay. I don't want to merge my B change because I'm currently working on this feature and this is a bug fix or something which should be added to all the branches. Let's say you forgot to do version change on release branch and you created a feature branch, which happens actually. You did version change in your feature branch and want to add it to release branch also. So people who are creating branches after from that release branch will have the new version, right? Let's do it. Let's check out our release branch. We are in our release branch. Let's see the history. This is the initial commit we have. Okay. Now what we can do is we can just do git cherry pick and get the hash of this commit, which is our bug fix, and we can just run this command. Now if you see the git history here, I have initial commit and a change. So I have selectively merged this a change to my release branch here. So this is very simple. It has saved me a lot of time. So you can also use this instead of just copy pasting your changes to your release branch and committing on a different commit. I have seen people do that. Do this instead, which will save you a lot of time. So that is it for Git Cherry-Pick. Let's move on to the next concept. So let's talk about Git Reflog. Git Reflog is kind of a safety net for you. Okay, Git Reflog is kind of a history which is more than commits. So when you do a git log here, you will see a history of commits, right? You will have a lot of commands to see git history, but Git Reflog is something special. It will store like switching of branches and doing cherry picks. It will store your activity so that if you lost a commit, you can get it back. There are a lot of scenarios we can do with Git Reflog, but here I will be only showing you one. Let's say you deleted your branch, right? How can you get the lost commit back? As you can see here, this is my Git log, and I have done some changes in my feature branch, which is I am currently on. The current head is on this commit, and my mains head is on a different commit, which is called this. So let's say you created feature branch and did some changes and made this commit, right? By mistake, you deleted this branch. Okay. Now, how will you get your changes back? And sometimes it happens when you work with Git is you do some silly things, like you delete the branch from here, but you have not pushed it in the remote. So there is no chance that you can get your commit back, right? But Git Reflog is our savior in this scenario. Let me do this blunder. I will move on to my main branch, and as you can see, Git log, I am here while I have created this feature branch and added this. Now what I will do is I will delete my branch. So I deleted my branch here. As you can see, I used a capital -D because this was just a local branch. It is not even pushed to remote. How can I get my commit back? I don't even remember the commit hash and everything. Luckily for us, when we do this, Git is not deleting this commit. It is deleting the label, which is feature cs1, which is pointing to this commit. Git will delete the commit at the time of garbage collection. It runs your garbage collection and it will delete the commit that time, but it has a long period. So after a long period only, Git will run the garbage collection and your commits will be gone. But when you delete your commit just now, and let's say after 6-7 years also, I think you will be able to get your commit back. Now what you can do is, instead of git log, you can do Git Reflog. So as you can see here, what I did is I moved from main to feature cs1 here, and then did this commit, and then I moved back to feature cs1 to main. Okay, this is where my current head is, which is this commit. Okay, but I have this commit which I did after moving from main to my feature cs1 branch, which I accidentally deleted. What I can do is, I have this git hash here. I can use this commit to create my branch again. So basically what I can do is git checkout -b. I can create this branch again from this commit. And once done, we are here. We can do a git log. And as you can see, we have recovered our branch and we have recovered this commit. So this is how Git Reflog helps you. This is only one scenario. There are a lot of scenarios in case of detached heads and a lot of other scenarios where Git Reflog will help you a lot retrieving your missing commits. You can also cherry pick your missing commits, as we learned cherry pick before, which we were discussing about. So you can also do that. So that's it for Git Reflog. You can dive deep into this. This is a very good concept. And let's move on to the next concept. So let's move on to Git Hooks. So this concept is very interesting and you can do this too. It will automate your workflow to a lot. So Git has a lot of hooks. we will be just talking about pre-commit hooks. Okay, so what hooks are? Hooks are some scripts you can run before and after every Git action. There can be hooks here, there can be hooks here before going to the Git server. There are a lot of hooks, but currently we'll only talk about pre-commit hooks. We'll see them in action and how they work. If you have some IDE and you are working on Java like IntelliJ IDEA, they give you option to have commit hooks, like it will compile everything before pushing, it will run sonar before pushing. So those are kind of hooks which we have. So let me show you how you can create your own hook. It will be very simple, but you will get the idea. Anyway, as you can see, this is the current workflow we have. We will code, we will state the changes, we will commit it, we will push to a Git server. Now before committing, I want to do something. That's why they are called pre-commit hooks. We have hooks here, we have hooks here, and you can write as many scripts as you can. You can write it in any scripting language. You can either Python. We will be using Bash only. So let's see the demo. So as you can see, this is my repo. I have not even created Git folder. I am showing you how to create a hook from scratch. So let's get into the terminal here and do a git init. It will create your .git folder. As you can see, it has created your .git folder. You can go into hooks. You can see there are a lot of hooks here. There are a lot of hooks in Git. If you dive deep into it, it will save you a lot of time. But we will be talking about pre-commit hooks here. Okay, let's open this file into VS Code. So as you can see, this is a sample hook it has given us. They have also written in Bash. So what we will be doing is we will be creating our own hook. So what you have to do here is you have to do nothing much. You have to go here, just do a F2, remove this sample. Sorry, dot sample. Okay, now it's done. Now we adding a hook I created in Bash here. I will not code everything here in front of you. I will be just copy pasting my hook and I will show you how it is working. Yeah, so as you can see, this is my hook. This is a very simple hook I have created. You can create more complex hooks here. What I'm doing here is before committing, I will be compiling all my Java files and I will be checking if they are compiling. And if there is a compilation issue, it will not let me commit. Okay, so let's do some compilation error in our program. The best compilation error. So now let's commit our changes. Let's do a git status first. These are the changes. We'll do git add dot. We'll commit. Don't use this kind of commit messages. It will get you into trouble. This is just a demo, so I'm using this. It will anyway not commit. So as you can see, I have staged my changes. I will be committing it. Yeah. As you can see, my commit has failed. If you do a git log again, there is no commit yet. I have not committed anything yet. Okay. So there is no commit yet means our commit failed here, right? Here also there was no commit, and here also there is no commit. Our commit has successfully failed. In this error also, this is given by my pre-commit hook. So as you can see, they are running pre-commit checks on Java application, and they found this error, so they cannot commit the changes. This will help you a lot in your Git workflow. Let's say you did some changes. Ideally, this kind of silly changes you will be knowing by just your IDE, or sometimes if you use Eclipse, it doesn't refresh. There might be times where you push changes which are not compiled. So what you can do is you can write your own pre-commit hooks or any hooks. If you dive deeper, pre-commit hooks, I will recommend running compilation checks, running your unit test, and running sonar, and put some other validations also if your project uses. And if those are failing, it will not commit the changes. You will be safe. Let's say if you are committing something recklessly, it will not commit. So it will help you a lot. So that's it for Git hooks. Let's move on to the output. So we are done with all of these concepts. Hope you have learned something new today and you can dive deeper into that concept. If you are here till now, please like this video and please subscribe to my channel if you like this video, and click on the bell icon so you won't miss any video. I will be posting more videos soon, and see you in the next video. Bye.